record.
There we go. Looks like we're live. Go ahead.
Oh my God, we're live. Hello, everybody. Good morning. Welcome to week number 11. That's the 10th of May in the year of our Lord 2000.
Tom, are you recording?
Are we recording? Yes.
Oh, no, I'm not actually. But yes, I am.
All right, now we are. I'll start again. It's called the SBAU Astro Hour, and it's for Santa Barbara's Astronomical Unit. And doggone if we're not only on Zoom, but we're on YouTube. I guess it's the SB Astro Unit channel, which we're just starting here, you know, a couple months into it and building slowly. And we may continue to do this after we open our Friday meetings, first Friday of the month, following the pandemic, maybe later this summer or fall. Got to talk about astronomy, black holes, exploding supernova, all the incredible space news. And boy, there's a lot going on just in time. We got our astronomy club, telescope people. The big one for many years here on the South Coast is now called Santa Barbara Astronomical Unit. You're welcome to tell your friends. You're welcome to join us. I got a feeling, gentlemen, that when we do get back into the Herron Hall, it's going to be a big crowd, if not the opening night, then the following night, because that's what happened with the restaurants. When we went orange tier recently, everybody flooded in. So we're hoping we'll get them all back into the Santa Barbara Astronomical, what do we call that? The Museum of Natural History. Star parties on the second Saturday. That's our big business meeting anyway. First Friday of the month, we get together and let's meet the gang. I'm Barron, Vice President. President Jerry Wilson is on the screen at the bottom. Morning, sir.
Good morning.
3 seasons for both of us. This, incidentally, is season 1, 2021, episode 11. It's the 10th. None of our mothers are probably alive, but our wives qualified yesterday, and I'm sure you took care of them. TomT in the upper left is our incredible wizard, technical webmaster, former president. Thomas, how are you? Good morning.
Good this morning.
Suzanne doing okay? We didn't think Chuck would. Yeah, Chuck is with us. Chuck McPartland, an outrageously essential outreach coordinator. Good morning. And who am I missing? We're missing Bruce. He was with us for a while, but let's meet the former Westmont College science instructor, editor of our incredible monthly newsletter that you can get on board. Tom Whittemore, hello, good morning.
Good morning. Good morning, everybody.
Tom has been given an assignment to work on a theme using one of the banjos hanging on the wall behind him. Let me just throw at you to kick things off, because later on we're going to do the night sky every night this week. We're going to talk about a bunch of stuff going on. But the Chinese rocket, is it going to fall on us anymore?
It fell.
It fell.
It did?
Yeah.
Where?
It landed in the Indian Ocean near the Maldives Islands.
Yes, right.
So just like the odds, 3 out of 4 odds, that because 3/4 of the planet is water. Thank God for the ocean. Did they get pictures of it? I guess we did. Oh,
somebody got images of it. Maybe there was a ship nearby.
Yeah.
Wow.
I saw a picture of an object on flames in the sky. So that might have been a picture of it.
Why do you suppose China can't control this? How do we do it? Do we know where our first stages of?
Anyone can lose control of things up there. It's anything. It's just an accident.
Do we know what they were? Is this parts of their space station that was launched?
No.
It was part of the rocket that launched part of their space station, I think.
That's what I mean. The lower stage. And only we have the technology to re-land those suckers on the launch pad, don't we? SpaceX.
China apparently is now starting to fly a clone of SpaceX's landable boosters. So they're
really, but not in this case.
No, not in this case.
All right, we got a lot to talk about. Mars NASA's rover, the Perseverance, has the little drone, the little helicopter that could, Ingenuity, that flew again, and I guess they'll keep flying it. We're supposed to be able to hear it this time. Did any of you hear it fly?
That's too far.
Yeah, I played their recording supposedly of it. It wasn't from the NASA site, though, I must admit. And it was just a really low hum in the background.
Yeah, why would that change the sound? Yeah, I'm curious about why the sound in a low atmospheric pressure, why would it change to a low sound like that? I would think it'd be a really high pitched sound in our atmosphere.
Well, its pitch won't change, but its volume sure will.
Yeah.
Really?
Yeah.
Sound waves down here on Earth go at different rates and different material. In water, they go faster, do they not?
Yes.
Yeah.
Denser material goes faster.
Yeah,
Okay.
low frequencies are more easily carried. You know, you
Right.
can hear low frequencies much more easily at
Mhm.
distances.
Okay, so on Mars, which is 1/100th of our atmospheric pressure, we barely get sound, or it's just goes down in
Yeah, needs a
Okay.
medium. Needs a medium, Ron.
it means a medium.
A medium. Yeah, sound has to have a medium, unlike light.
To travel through.
And just like the tracks on Mars left by our rovers, stuff that's never been there before is now starting to pollute that planet. aren't we?
Yeah.
Off-road vehicle.
Yeah. Shall we talk string of lights in the sky? Tom Totten, I think you knew a lot about this, and you published. We got 5 pictures in a row on our inboxes from somebody.
Oh,
Those
that's
were-
true. I could try to find that. If you give me a minute, I can find that.
All
Those
right.
were from
Well,
Mike
you're looking it up.
And I know that on Ed Hat and on Nextdoor, people here in town have been asking, hey, Thursday night I saw 40 airplanes flying in a row. What's going on? And so people aren't aware of these Skylink satellites.
Yeah.
Well, I hang out at the Farmer Boy on Sundays, and yesterday, Nick, the manager, who's a good friend of mine, showed me his picture taken in Yosemite. He said, I've never seen anything like this. And it's a string of lights in the dark sky.
Yeah.
And they have a good sky. And I didn't see any stars in this picture because it was taken by a cell phone. So those must have been very bright, even though you could barely see them. And everybody's conjecturing UFOs again, but there's a reason for all this, isn't there?
Oh, yeah.
Yeah, this is
Okay.
the fantastically large constellation of satellites that SpaceX is putting up called Starlink. And it will
Yeah.
provide internet access to anyone, anywhere on the planet for $100 a month.
So we're going to
Actually, I
continue to,
think yeah.
What'd
But
you say,
there's
Chuck?
like a $500 equipment startup fee or something.
so we're going to continue to see those lights. They're in a row going around the
Well,
Earth.
Each
They
time
just-
there's a new launch, you'll see a bright string like that, but they gradually go up in orbit and get dimmer, although they're still visible to telescopes.
Yeah.
Hmm.
I saw a picture that one amateur took of the night sky with a wide angle camera, and it looked like a meteor shower, but there was no radiant. There was no one place it was coming from. It was just all over the place with
Yeah.
these satellites. It went on for like an hour. He took an hour exposure. I mean, not a single exposure, but it was a video.
But this is the result of one of those launches we've been hearing about over the last couple of
The
years that are,
ones he was showing was multiple launches. There's thousands of these things up there now.
Yeah.
And
The one that's in Mike Chibnik's picture is from a single launch, and each launch they launch 60 at a time.
Yeah.
60
Yeah.
satellites.
Yeah.
Yes.
And do each and every one of them go a different direction?
Eventually.
They each go into a different orbit, but they start out in a long train, like in the picture.
So they all have little rockets on them,
Little thrusters, yeah.
thrusters. And they're all equipped with radio waves to beam it to Earth and the cameras.
And solar panels, and that's why they're reflective.
And this is for our internet.
Yeah.
Does this connect the whole Earth, I suppose, in some of the most barren?
That's
remote-
the point. Yeah.
It can. I don't think North Korea wants to participate.
Stupid Kim Jong.
I think you have to buy like a $500 antenna system to pick up the signal, and then they're charging about $100 a month for the internet access.
Well, somebody who's not very happy about it is a gentleman named Robert C. Richard. You said move. Can I read part of his letter, gentlemen?
Sure.
It was sent to us online. Hi, all. The current June 2021 issue of Sky and Telescope magazine has a great article about these satellites titled Beyond Starlink, the satellite saga continues. As the article points out, Starlink is only the beginning of efforts to fill near-Earth space with these types of satellites. It's very discouraging, he says, to see our skies further compromise in the name of progress. Is it going to get that bad with satellites? I mean, streetlights is one thing, but just because we see a big.
Ron, they're talking 40,000 of these satellites.
But normally, it's a big event on a certain night when we see one, the ISS go across.
Well, that's because it's super bright.
And it's easy to see, yeah.
Well, is this string of lights that we're seeing, these satellites, the Starlink, are they closer to us, or are they?
Yeah, they are closer, but they're also much fainter. As someone pointed out here, it'll show up in astrophotographs, but through post exposure processing, those things can be eliminated. So for us amateurs, it's not really a big issue.
Well, there's a lot of space junk up there.
Yeah.
You know, there's tools from space work and EVAs or whatever they call those things on the shuttle still going.
And space junk is a big problem. And if you've got 40,000 of these and they happen to collide with something, you can get a chain reaction of debris collisions that could lock us out of space travel for hundreds of years. It's called the Kessler syndrome if these things start colliding with each other.
At 17,000 miles an hour.
Yeah.
Yeah, you saw the little brother of that effect in the beginning of the movie Gravity.
Oh, yeah. Well, of course, that was all graphics and, you know, special effects, but sooner or later that's bound to happen. Do they track as much of that as they can? I imagine.
No, they're not bringing much of it back. You're supposed to, when you put something up, you're supposed to have it capable of re-entering on its own by command. So it's controlled re-entry into the ocean or something.
Okay.
But early satellites don't do that. And I don't know if Starlinks do it.
I just want to mention that Tim Crawford asked the question, will astrophotography suffer? And I think you kind of answered that already, Jerry. But
Yeah, not really.
Well, if you do a lot of processing, you can take care of it. But if
That's
you're
right.
just doing casual astrophotography, you're doomed.
Yeah, that's right. You have to have a large number of subframes in order to eliminate a satellite on one subframe.
Well, I heard of somebody somewhere that thought he was going to go up and start a cleanup service in space someday.
I read that. Yeah.
You heard about that too?
Yeah.
Seems like
I'm not sure what he intends to do, whether he's going to go actually, grab each satellite one at a time, a la James Bond, or just drag a net behind him, and in which case the satellites would win. So I don't know.
Carbon dioxide laser.
Welcome aboard there, Bruce Murdoch, longtime active
Hello.
member, president of the Santa Barbara Theater Organ Society. Nice to have you aboard, my friend. Now we have a full screen. You want to get in on this? Did you see the lights in the sky, the string of lights?
Well, I did some photo editing on Mike Chibnik's photos.
Oh,
brought the satellites up, and then he emailed me and said, "What did you do?" So I gave him what I did in Photoshop to make them a lot more visible. But yeah, you read like probably what you got here. Elon Musk wants to just litter the sky with these things. You will not have. I don't think you'd be able to take astrophotos without having one or more streak across your picture.
Yeah, probably not.
It's not just Elon too. It's Amazon and a bunch of other services.
Yeah, and Russia's thinking of doing it too.
Yeah.
Come a long way, baby, since Sputnik, when it was just one little dinky thing the size of a basketball.
Is Sputnik still up?
No, it re-entered.
Okay.
I think there's a Vanguard that's still up though.
Yeah.
It's probably silent though.
Going back to what you said earlier, Baron, about satellites or rockets getting lost. Several years ago, about 10 years ago, maybe 15, there was an object that was spotted suddenly orbiting the Earth, and they did an analysis of it, and it was very low density and very bright. And finally, they tracked it down to a booster stage. I think it was an Agena booster stage, second stage from one of the very first launches that had gone out and had orbited the Earth, but then it changed into a sun orbit and everybody lost track of it. And then we caught up with it again. And for a while it orbited the Earth again, all of a sudden.
Wow.
That was one of those Earth's second moon things that they were talking about.
Yes.
Well, who's our orbital expert? Is that you, Whittemore, or are you, Bruce? Now the moon, for example, slowly is leaving us like half a foot a year. It gets a little further.
We're like the width of a hand.
Yeah, I think it's smaller than a foot.
Yeah.
So it's
Yeah, it's
eventually going
losing
to leave
energy.
us. What?
It loses energy to the tides.
Okay, so
Well, actually, the tides are adding energy to the moon and pushing it out into a farther orbit.
Oh, really? I
Yeah,
thought it was
farther
the
out
other
is
way around.
higher energy, but lower speed.
Yeah.
my question is, do all orbits die or end sooner or later? Can you just orbit?
It depends on their orbital dynamics, what's around them, and what kind of objects are doing the orbiting. Are they rigid spherical objects, or are they flexible objects that have internal friction heating?
Or are there magnetic fields or other things involved?
Right. Yeah.
Well, also,
Yeah.
if they're in Earth orbit, they get run into the molecules, and that's down.
Well, you're really distorted there.
Yeah, your voice dropped out, Bruce.
Oh, I'll
Repeat
move the
that.
microphone closer to me there.
It's cutting out there, Bruce. But
What's-
you'll see it on the replay, I guess.
How is that?
That's
We're
a
only
little better.
getting about every other word.
Oh,
Sorry about that. That's
I can hear
okay.
just fine.
There you
Uh,
go. That's
that was
nice.
better.
That's good.
There you go.
Okay.
Well, okay. Back
So
to the
what-
early part of the solar system, our planets were all over the place. Jupiter came in, and were we always 93 million miles away? Do you
There
suppose?
were probably not. There were other planets too.
Oh, there were.
Yeah, remember Theia, a garden spot.
Okay. Shall we do, what shall we do? Oh, the rotating binary asteroids who have names like Malate. No, that's the catalog. What am I looking for here?
Patroclus and Menetius.
There you go.
Apparently, there's a real wide range of spellings of those things.
Yeah. I've got Monotus for the second one, and
Well, it's Menetius. That's just the Jerry's friends kind of guessing at the spelling there, I think.
Yeah, I think so.
Petrocius, it looks like to me, and Minoa.
Patroclus.
Patroclus. Oh, that's an L, not an I.
Yeah.
Okay, and Mencetius.
Menetius.
Okay.
Patroclus and Menetius.
All right. This is the occulting report, because occulting is big time. I guess that's probably taken off, wouldn't you say? And you're an expert at it, Chuck. So what have you occulted lately, and how do you do that?
Well, this was yesterday morning. Patroclus and Menetius had an occultation. There was an occultation where they went in front of a star from our point of view.
Okay.
And they are a target of the upcoming Lucy mission that's going to launch in October, we hope. And as you can see at the bottom of the screen that Tom is showing there, that it's a binary system. They're roughly the same size. And they orbit a common center of mass. And they are the first binary asteroid discovered in the Trojan L5 region orbiting Jupiter.
Oh,
There are two regions, Lagrangian points around Jupiter, 60 degrees ahead and 60 degrees behind it in its orbit, where you can stably sit in orbit. And there's groups of asteroids that are called Trojans. And the L5 group, I think it's the trailing group, is the Trojans. And then the leading group, the L4 group, is the Greek Trojans. So they're named after heroes in the Iliad and the Odyssey.
What are the red lines and the blue lines in that picture that we just saw?
I don't know what Tom was showing there. I think
Actually,
the blue is Earth's orbit, and the white up there is Jupiter's orbit, and then the red is the trajectory of the Lucy mission.
Oh, okay.
So
They're
it's
gonna
going to
go
make
out.
several Earth flybys, and it's going to visit both sets of Trojans. It's got like a 12-year mission.
Now,
And
is the-
Patroclus and Menetius are on its target list. They're the only Greek asteroids in the Trojan camp and the L5 camp, because they were discovered because Patroclus was discovered and named before they came up with the convention of which were going to be Trojans and which were going to be Greeks. And then Menetius was discovered later, like in 2001. And
what were the gold objects, gold circles in there that are spotted around?
Those are the asteroids that Lucy is going to visit.
Oh, okay.
So it's going to visit one that's in the main asteroid belt there that you can see, and then mainly it's going to visit Trojans.
So that's the one between the blue and the white line is the main asteroid belt.
Yes.
Yeah.
Hmm.
And if you go to the Lucy webpage, there's also a nice animation of that. Oh, I guess this was an animation too, if you'd fired it up. And so you can see
It's on my screen. Okay.
So you can see in the middle of that previous, and I also sent it separately to Tom as an image. Back in 2013, there was also an occultation by Patroclus and Menetius, and I actually participated in that campaign too. But I was way out of the path, so I'm not one of the chords there where they got the shapes of the asteroids and they really pinned down their sizes. But this was happening again on Sunday morning at 1:37 a.m. our time. And Jerry's friends got Menetius it was passing over Mexico and Texas. And I sent Tom a map of where the paths are, and it has all the paths. Southwest Research Institute is running this, is helping to run this Lucy mission. And so they set up a group of observers to catch the occultation, because they want to pin down the orbits and stuff really well on these two.
Tom, could you show the pictures that Chuck is referring to?
Yeah, just a second. I'm trying to get there.
Okay.
So they had, 40 or so lines on their map, and that was April 24th. And they got a bunch more, probably at least that many from IOTA, which is the group I'm in, International Occultation Timing Association. And they haven't even put those on the map yet. So you can see when Tom gets it up that they're really covering the orbits there. So the one that's kind of pinkish down below, that's Menetius, and you can see how that goes over Texas.
Oh yeah.
And then the more orangey one is the one going over California here. And so we were very near the center line. I think it was up by Atascadero somewhere. And for Patroclus, which is the bigger one of the pair. And so I went out and set up my stuff.
Oh, yeah.
Now,
so why are there so many lines?
those are all the observers.
Oh, okay. So, okay.
Which is your line?
So my line was not on there yet.
Oh.
Okay, but there was a line going right through the center of Santa Barbara, and it's some guy who was observing from Southwest Research Institute. He was observing in Nevada somewhere. And so my line is about 5 kilometers north of the one that goes right through Santa Barbara.
Okay.
And it's not showing on this because this dates from April, late April.
Okay.
And
is
I'm
that,
trying
go
to
back
get
one,
to
is
where
that your,
oh, that's
that.
an
Nope.
older one I sent you there, Tom.
Okay.
So
so this is your actual timing.
this
for it.
is my actual timing. Now, this isn't the order I wanted to mention things. So
Oh, sorry.
So Tom, I sent you an email that has kind of the order here. If we could go look at both.jpg, that shows the previous occultation results from 2013. And you can see both asteroids in there and the chords that went across them.
Which plot is it that we should be looking at?
Tom hasn't put it up yet.
Oh, okay.
What's it called, Chuck? Do you know the name?
Both.jpg. OCK 2013, both.jpg.
Shoot. I don't know what happened to it. I got all 9 of your photos. I had them.
Yeah. Okay, well, anyway, we saw it earlier when Tom was showing the Lucy page where you could see the 2 asteroids and you could see the chords across them. And then, so the next one was this one here that Tom's currently showing. This is the initial lineup of observers. And there were a bunch more added. So these are going to be really dense. We're going to get really good coverage of these asteroids, assuming people had good weather. I mean, not everybody had good weather for this. And then, so it was in Scorpius. So I sent you a file finderwide.gif.
Yeah.
The
in Scorpius. So this, okay, so there it is. So here's No, that's not showing Scorpius.
Yeah.
Oh, there we go. Okay. So you can
It's a
see here,
weird
there's
drawing.
Scorpius, a scorpion, and you can see a rectangle there. That's a 30 arc minute field of view. So that's like moon size. And in the center, there's a little crosshair right near Rho Scorpii. And that's where the target star was. It was magnitude 11, so fairly bright for these things. And that's the star that was going to wink out when the asteroids went in front of it. And so, so I set up my equipment. So now I sent you a packed setup.jpg that shows all my equipment kind of packed up and ready to go.
What happened to it?
Yeah, that's not here. Okay, so I can fit all my equipment to do a mobile asteroid occultation into the back of my car. And it's my telescope and a laptop for recording the event, a power supply, you know, a battery and an inverter to give me house current to power the monitor, plus 12 volts to run the camera and the telescope. And I have a camera. There's here we go. Okay, so this is my entire setup, all set up. So there's the telescope. It's just a 5-inch refractor. You can see the cameras hanging off the end there where an eyepiece would normally go. And then down, if you scroll downward, I have a table set up, and there's the laptop to capture the video. Now off to the left, there's a black box. That is the video time inserter. That puts GPS information and timing information onto the video so that you can get accurate timing information for the occultation. And then just below that black box and above the clipboard, there's a video digitizer, and that's what lets me capture it into my laptop. And so the screen that's showing on the laptop, you can't read it, of course, but it's currently showing all the GPS information of the exact observing location.
Okay.
And then off to the right, there's a little white box on a line, and that's to control the camera, so you don't have to go up and jiggle the telescope. So you can change settings on the camera. The camera does integration, where it can take multiple video frames and add them together. So it's just like taking multiple subs when you're doing astrophotography. You can see dimmer things, but you lose some of your timing resolution. So depending on the brightness of the star, you may get better or worse timing resolution because you have to integrate the image. I had to integrate for a quarter second to get this star that I did. And then the black little keyboard there on the right, that is to control the telescope.
Mm-hmm.
So
What kind
it's
of
a go-to
camera?
mount, an
camera is it?
astrophysics mount there, German equatorial mount, and you go to the target area, and then you can do fine adjustments with that keypad.
What kind of camera is it?
Okay, so there's also a camera setup.jpg there somewhere that shows just the camera. So the camera is a Waytech or Watek. It's a Japanese company, makes black and white low light surveillance cameras for security systems. And this one's been modified a little bit so that you can take the integration, so that you can do the multiple exposures. There it is. Okay, and this particular modified model is called an Astrovid Stellacam 2. And it's a very sensitive camera. As you can see, it's not very big. It's just a little like 1.5 by 2-inch cube or rectangle there. And it attaches where you'd have an eyepiece. And then it's got the connections out the back. There's power and there's video, and then there's the controller to set the integration levels. So I set that up yesterday morning, and if you go to the file patroclus.jp, this shows the 2013 results of the occultation, and you can see each one of those lines going across is where there was an observer.
And I take it the red line is where they saw something.
Right. The red lines are the positives. the dotted blue line is the trajectory of the asteroid during the course of all these observations, because different people were in different parts of the US, so they saw it at different times, and those all have to be brought together to get the shapes of the asteroids.
Uh-huh.
And we're only seeing a tiny piece of it here, Tom, but, or I am maybe, just because I have my screen a little smaller. But you can see how they got both asteroids and they got the shape, an idea of the shape, and that was in 2013. So the new results when they come out here, and they're just starting, SWRI is just starting to collect all the results today, will be much denser. So we'll get a much better profile of those asteroids rather than just the simple ellipse. You might even be able to see surface features if there are big craters on them and things like that.
Mm.
Okay,
What was the star?
Pardon me?
What was the star that it occulted?
Oh, you know, it was pretty bright. So it was a Tycho star, but it's not one that will have a name that means anything to anybody.
Oh, something you just barely see. And only one of the two rotating asteroids did the occultation?
For me, but
For you.
Menicius was seen by Jerry's friends in Texas.
Okay.
So they, you know, the shadows passed over different parts of the globe because there's a separation between the asteroids.
Ah. And
okay, and then if you go to patroclus.jpg, oh, there's all my equipment packed up, sitting in the driveway. So
let me make a comment on
the patroclus.jpg. That shows my view through the video, through the camera of the target star.
Okay.
If Tom can find it.
Same stuff you bring to the star parties.
Yeah, this is similar. I don't usually bring the Stellacam, the little black and white camera, because there's a color camera we use for the public events.
Aha. Well,
so the patroclus.png, if you can find it, Tom, is the view I had with integration. Here you go, of the target star area, and near the center of the field of view is the target star. I'm not. Yeah. Okay. So it's the one you're circling right there. That's the target star. And this is actually more integration than I used to collect the data, but just to make it a little easier to see the star. And you can see I don't have square pixels, so all the stars look like a little bit rectangular there.
Huh.
And so that's the star that I was watching, and that's what it disappeared briefly when the asteroid passed in front of it. So if you go to patrocluscomposite.png, there are analysis programs that are written in Python that are cross-platform that you feed the video to, and they will extract a light curve of the event. So here's the light curve extracted from my video, and you can see that it's noisy. You can see how the amplitude of the star at various measurement points is jumping all over the place, but right in the middle there, you can see where it just drops way down. And that was 4.3 seconds worth of occultation by the asteroid at the speed it was going. So it made the star disappear for a little over 4 seconds.
Chuck, what are the numbers on the left-hand vertical axis? And
that's just an idea of the intensity of the star image. So the number of pixels that were lit up on the camera, basically, and how many photons had been collected by that particular little bin. So it was twinkly. You know, there was some upper altitude wind, and so that made the star really twinkly. So that's what you see with your eyes. The twinkling is what you see with all those blue dots jumping around up and down there. And the baseline brightness is that blue line that goes horizontally across. The red is when it disappeared. The green is when it reappeared, as far as the timing guess by the analysis program. Because I was binning at this 1/4 second, it has to kind of estimate where within that 1/4 second that things actually happen. And if you go to the patrocluscomposite.png, that shows you, so in the analysis program, I selected both my target star plus here we go. So the target star is in blue, and in green is just a background star to use as a reference. And then down below in, I think red, is a no star area. I picked an area of my screen where there was no star. And that just shows you the background noise that you get from both the camera and any kind of cosmic rays coming through. You know, it varies depending on the temperature of the camera, whether there's any haze in your sky. So that's like the background zero level, in effect, that gets set when doing the analysis.
So this is a relatively rare thing to happen, or is it every night, many of them happening? Just curious.
There's many of them happening. Well, there's a couple, I would say, not many. There's a couple happening every night somewhere across the world.
Okay.
For Santa Barbara, I get about 10 to 20 a month that are possible to try from here. Because there's hundreds of, I mean, there's millions of asteroids, and there's, you know, hundreds of thousands that we have orbits for. And if they're passing through a busy part of the sky, you might even get multiple occultations on the same asteroid. And so this is, Tom has gone to the IOTA site, where you can find out when there's going to be an occultation and where it's going to happen, and various details about it. And if you click on the links in there, you get detailed maps and stuff. And so this is how people plan ahead for when they're going to try for some, you know, whether they're worth trying for with their telescope. Like, I only have a 5-inch telescope, so I'm basically limited to brighter stars that I can try, whereas people with, you know, 16-inch telescopes can try much dimmer events.
But if there's ever a major star involved, a Vega or a Regulus or a Betelgeuse or something, that makes worldwide news, but only you can see it at any one time. Within the people 100 miles from here wouldn't be able to see it. It'd be off.
That's correct. The path of the shadow width is the size of the asteroid, because stars are so far away. Their light is essentially parallel when it reaches us. So the size of the shadow on the Earth is the size of the asteroid. There was, a couple of years ago, there was an occultation of Regulus, which is a bright naked eye star that was going to pass over New York. And so everybody got all excited, and they were going to go out, and there were even apps developed for cell phones. The star was so bright that you could hold up a cell phone and do an occultation with it. And there was all this preparation, and then boom, clouds over the entire East Coast. So nobody ended up seeing that one at all.
Tell us about these Trojans. They're much further than the regular asteroid belt by tens and hundreds of millions of miles, wouldn't you say?
They're out by Jupiter, yeah.
Okay. Do they fill the Jupiter orbit, or are they just clustered in a couple of spots?
No, they're in the 60-degree spots, leading and trailing, because those are stable Lagrangian points.
But basically, they're the same thing we see between Mars and Jupiter in the regular asteroid belts. Just
they may be more primitive, because they may have been captured by Jupiter and kind of traveled with it, and so they may capture a cross section of asteroids and Kuiper belt objects that were captured when the planets were moving around. And so Patroclus and Menecius, from these occultation studies, we've managed to refine the orbit and the sizes, and now we have an idea of their density. And Patroclus and Menecius are about 0.88 grams per cubic centimeter, so they're less dense than water. So that's telling us that they're either rubble piles or that they're icy, and the thinking is they might be icy. So these are like trapped, potentially Kuiper belt objects that Jupiter grabbed early in the age of the solar system, and they've been preserved there. So that's why this Lucy mission wants to go look at it. It's called the Lucy mission. It's named after the fossil Lucy that was the primitive anthropoid.
Yep.
And so they're hoping to find these primitive asteroids or primitive objects that have been trapped in these Trojan orbits.
Okay. I happen to remember the diameters you gave, 113 kilometers, which is about 90 miles across, and the other is about 10 miles smaller.
Yeah, that's more like 60 something miles across, 60, between
Okay,
60 and 70 miles across for Patroclus.
That doesn't qualify them as dwarf planets, so does it?
That's correct.
So they'd be kind of lumpy. They wouldn't be spherical like a sphere.
Well,
need to be
they're
around.
roughly spherical. and if you scroll back up, that Patroclus there, it says 140 kilometers. That is the effective size of the two of them together.
Oh,
both Patroclus and Menetius. That diameter in kilometers of 140.
huh.
That's actually the both of them. That's
So
kind
that
of
includes the space between them then, right?
yes.
Yeah.
You'd think you'd get pairs more often, that would be a common occurrence, that they find each other, they're all teaming and going different directions anyway. Sooner or later, you'd think there'd be a bunch of them doing the binary thing, wouldn't you?
There are a bunch, but in the inner solar system, things are a little too active to easily get captured. It's
Okay,
probably easier for that to happen way out in the Kuiper belt where things are moving more slowly.
I see. So it's a rare thing to actually see a star being occulted with the Trojan asteroids. Most of your time is spent in the regular asteroid belt because it's close.
Right, because there's a lot more of those.
Oh, and there's more of those.
Yeah.
Of course. Interesting. Well, look, that's great. We're going to have a report from you every week if you're doing that on a regular basis. Whittemore, what do you got to say?
Something much more mundane, if you don't mind.
How about you, Bruce?
So I was just,
wait.
for those who like to
Tom,
just,
Tom has his talk, yeah.
What?
okay. For those folks who like to, just look for, planets that are just really beautiful with your eyes or maybe binoculars. There's just been a nice congregation of Venus, Mercury, and Mars lately. So what I've been doing lately is after the sun goes down, roughly 8:15, something like that, you can see Venus very low in the northwest, okay, just getting ready to set. We have some mountains out there, so I mean, technically it sets a little bit later, on a 0 degree horizon, but we don't quite have that. But you can see Venus, okay, and then if you look further up, you'll see Mercury, not nearly as bright. Mercury for us anyway, sitting behind the hills, more like about 9, okay? And it turns out that on the 16th of May, Mercury is going to be 22 degrees east of the sun. So it's going to be the furthest east of the sun, okay, for us here. But it turns out Venus and Mercury are going to be very close to one another, okay, on the 28th of May, okay? They're going to be about 4/10 of a degree from one another on the 28th of May. So that's something to look for. The other thing I was going to mention too is now Mars is high in the sky, much higher up in the sky as you look up into Gemini. And what I've been watching lately is Mars basically marching up through Gemini in what they call prograde motion, okay? And last night it was next to this fairly bright star in Gemini called Mebsuta, which is a yellow giant, okay? For those of you into stars, it's a G8. It's a G8, so it's going to be yellow like our sun is yellow, okay? But if you put Mars and Mebsuta back, together with binoculars, it is a beautiful contrast. You'll get the yellow star, you'll get red Mars, okay? So those are kind of things I've been, looking at lately in the western sky.
Mars is now.
Thank you, Tom.
Oh, yeah, thanks, Jerry.
Mr.
Bruce,
President,
we
you
can hear
did
that.
post the night sky for this week, and we may not have time to go night by night. He did mention Mercury. That's passing 8 degrees north of Aldebaran, 8 o'clock tonight, I guess. And where do you get those? So you can pass that on, and everybody that wants to read these nightly ascertainments can just go online or have to subscribe. Is it online by any chance?
Yes, it's the ones that I use as a basis before I edit or rewrite things. It's on the astronomy website. I think it's called Sky Week or the Sky This Week.
Okay.
So just Google in Astronomy Week and you'll get a whole list of things. Sky and Telescope has an excellent selection of things that's very similar. It's just I happen to use the Astronomy magazine one. Bruce, you were going to say something?
Yes, the Argentine is going to open up movies now, starting the day on Friday the 21st. And we got
You're
Bruce,
totally
your voice
garbled,
is
Bruce.
not working.
We're getting every other word again.
now.
Gonna need to borrow Gary's
You
microphone.
hear me?
I think we're gonna have to mute you, Bruce.
Sorry about
How
that. my
about-
friend.
How about now?
Still dropping out.
Still cutting out a little bit.
Yeah.
Maybe one of these microphones, like or the lens combo that they sent me, might help you if it plugs in. Are you on a laptop, Bruce, or?
He's on a tablet,
A tablet.
cheap tablet. So
Well, suffice to say, the moon's down to a crescent, and this is the time of the month you guys like to watch the moon, isn't it? When there's a sliver there and there's shadow.
Practically new now, Ron.
Well,
I just barely saw it a couple of mornings ago. It's pretty slim.
And in 2 nights, there's going to be this thin little crescent moon right next to Venus.
All right,
And
so it's
Venus
coming
will
up.
actually be easier
Yeah.
to see. So get Venus in binoculars, and there'll be this really, really thin crescent moon right next to it. It'll be beautiful.
that's right. That's Wednesday, the 12th. And then it gets even more crescent, and I guess it's a thin little thing on Friday, and I guess we get a new moon by the weekend, probably.
No, we've got the new
Oh,
moon
no,
already.
we just had that. Yeah.
Oh, this is
Well-
the new moon now. I'm sorry.
Yeah,
I
you
thought-
can see in the picture that Tom is showing, you see there's a blue circle at lower left, just above the horizon.
I'm not sure. Oh, you mean the glow?
No, the
Oh,
glow
I
is
see
the
it.
sun.
I see it. I see it.
Yeah, this was, I took this off the Sky Planetarium software over the weekend. So it may be trying to represent the new moon.
Oh,
You have to scroll to the left,
okay.
Tom.
Was that-
There.
Was that sent to us by somebody? There it is.
No, I dug this off a planetarium thing called but it would have the moon, it would have the label moon on it if it was the moon. So that might not be it. This was before the moon was new, or at the time it was new.
Mhm.
This is from the Sky 6
Oh,
software program.
so it goes without saying that all 8 of the major planets can be seen at some point of the year. None of them are denied us. Gentlemen, there's Mercury, Venus. Okay.
Right, Mercury, Venus.
Rest are in the morning.
Got
Yeah.
it up early. Well, I'm used to that. I get up early. Canis Venatici. Does anybody know what that is?
Canis venaticorum or Canis venatici is the
Mhm.
hunting dogs.
Mhm.
The hunting dogs. It's a constellation based on, well, just below the Big Dipper's. Yes,
It's Greek, I think. Isn't
Yeah,
it?
it's
Latin.
Greek. It's the 2 hunting dogs chasing the bear.
why don't I remember 2 hunting dogs as a constellation? Was that up on the
I
inside of the
think they
planetarium?
belong to, Chuck, don't they belong to Boötes?
Boötes, the herdsman, has got the
Yeah.
dogs on a leashes, or
Yeah,
he's
yeah.
controlling the dogs, and they're chasing the bear.
They're chasing Ursa Major.
Yeah.
You remember their names, Chuck? The dogs?
Tara and Asterion.
Nice work.
And the bright star, Alpha Canum venaticorum, gets mentioned in Jerry's little blurb, but it's also called Cor Caroli, Heart of Charles. I think it was named by Halley or somebody after King Charles of England, and it's a beautiful double in a telescope.
Yes. It's
Double
also
like,
a jump off star to find M3, and use that, yeah.
Bruce, you're trying to get through again?
My ear, can you hear me now?
no,
Yes, you're chopped up, my friend. Sorry.
Say again?
Yeah. Well,
All right.
let me get down to the wire here. What do we got? About 10 minutes to wrap things
Oh,
up.
yeah. Boy, time goes quickly.
I'd like to get a plug in. We're going to break for a commercial from Tom Totten. Are you available to talk about tomorrow night's workshop? How you get on board that? Totten?
sure. If they contact webmaster at sbau.org, they can, if they have an interest in participating in the telescope workshop, I can give them the link so that they can connect in on Tuesday nights at 7:30. So it's always Tuesday nights at 7:30. Just like this program is always Mondays at 11 a.m. in the morning. But of
And-
course, they're both of them are recorded generally, and we post those. They're posted on our YouTube channel.
Well, President Jerry, you were on board last Tuesday night. What was it like? How many people showed up on screen?
I didn't count, but we've had up to 12, and I think last week was about 6 or 7 or something.
Is
I
that
thought
right?
it was 8, but yeah.
Yeah.
You have had special guests on that, haven't you? Do you go on board, Chuck?
I was there last week, I think. Yeah, I go pretty often.
Okay. And it's Tim Crawford, right? It's his baby, pretty much. And it's
Well,
Tuesday
Tom
night.
Cotton has been, of course, the MC, but Tom,
Yeah.
Tim shows up here and there.
Okay. Otherwise, we're about to break loose, aren't we? We're in the orange tier. LA, I hear, is in yellow. And gentlemen,
We're getting feedback when Aaron talks. We're getting feedback from your microphone.
well, I'm up close to mine, but that's all right. Probably too damn close. May is the last chance to see Comet C 2020 R4, which is known as Atlas. It's on its way out.
Yep. It's faint, and so the last chance is dictated by the moon, which is now in a early crescent phase. It's a waxing moon, and by the time it heads to full and becomes close to new again, Atlas will be far enough away and faint enough that it won't be easy to see for amateurs.
Damn it.
Well, none of us have really been, I haven't gotten a lot of reports about anybody really zeroing in on it, just a little fuzzy patch in the sky.
No, mostly probably for imagers right now. It's up in the area we've been talking about, Coma Berenices and Canis Venatici. So this is a good time for, it's passing through a region of a lot of galaxies because we're looking out at the axes of rotation of our galaxy away from the Milky Way. So we can see a lot of other galaxies at this time. It's passing through them. So there's a lot of opportunities to take pictures of the comet and the background galaxies.
Does it look like a galaxy, only moving different?
It looks like a faint fuzzy.
Okay.
You can see there Leo the lion, and off the tail of the lion is Coma Berenices, off to the left from where, there we go. So you can see this concentration of galaxies, and you can see that Melat 111 or whatever it is, the cluster of stars that kind of makes up Berenices' hair right there. Yeah.
Yeah.
So it's going through Coma Berenices, just south of.
Yeah, Bernice's hair. Yeah.
Bernice's hair. Yeah.
And we'll continue toward Leo by nightfall, heading straight for Zosma. There's a new one.
Mm-hmm.
Zosma is the rear end there of the lion.
Oh,
Right there. Yeah.
Yeah, the very tail end is the nebula.
Yeah.
Right there. Yeah, yeah.
we don't
Which
have
means little tail.
Yeah.
Oh, there it is. I miss those little animated illustrations on the inside of the planetarium you throw up.
Yeah.
We all do. Well, continuing toward Leo by night and then 1,000 years. I guess that means it goes way out into the Oort cloud or.
Yeah. Probably Kuiper belt anyway.
Kuiper belt anyway. Yeah. Oort cloud. Do we get comments from the Oort cloud or are they all Kuiper belt?
No, we get them from the Oort cloud. That's how they figured out the Oort cloud was out there, because you'd get these comets in really high inclination orbits, whereas the Kuiper belt is kind of in the plane of the solar system.
And yeah, it's more like a part of the solar system in a plane, and it's not over us or below us.
Everything for us started as a spherical cloud of gas, roughly, but the inner stuff collided with itself and came up with one winning angular momentum and collapsed. And as it did, it collapsed into a disk. But the outer part, the Oort cloud, is so diffuse that it hasn't experienced those internal collisions that have caused it to collapse. So it's only very partially collapsed, if any at all.
And as you guys all know, every damn star out there, and there's billions, hundreds of billions of them, probably have the same thing going for them, don't they?
Probably.
Bunch of planets, their own Oort cloud, their own Kuiper belt, their own asteroids in various, but there's no way we can see them yet. We're just barely picking up exoplanets.
Mm-hmm. You know, we had that visitor from outside of our solar system, from interstellar space. Oh, Mumu, I think. Yeah, but there was a second one a few years later, and it was Borisov or something.
Borisov.
Yeah, Borisov.
Yeah. Does anyone know about that?
It was a comet. It was very cometary, and it had a lot of nitrogen ice. So they're figuring it formed in a something like an Oort cloud of another solar system.
Okay.
Why couldn't it have come from our Oort cloud down?
Because of its velocity. It
Yes.
couldn't have been gravitationally bound to the sun.
Oh,
But they did find a star, one of the Gliese stars, of something like 7 light years away or 13 light years away, a close red dwarf star that if you project its trajectory backwards, it may have come from.
Mhm.
I see.
well, whoever latched onto those two visitors, could they keep their telescope centered on the damn thing, or would it be moving too fast and they'd have to adjust and keep following it? Just curious.
Yeah, we only saw Oumuamua for about 11 days. It was on its way out.
I know, but did you? On
No.
your telescope?
No.
Why
This
not?
was back in October of 2017.
Yeah.
And it was fairly dim already.
Oh, it was.
And you remember Avi Loeb went out on a limb, thinking it might have been some sort of not a spaceship, but a space sail and things like that. That's been pretty much dismissed. And Chuck sort of referenced that by, there've been some recent articles that show that from reflective measurements that Oumuamua probably had a lot of nitrogen in it, okay, a ton of nitrogen. So they don't know what it is, basically.
Why did they say it was long, cylindrical? Why? What
Because of the variations in its brightness, they could tell it had a long axis, whether it was pancake shaped or whether it was tubular.
Right.
Yeah.
Well, now I heard a story, and I know you've heard this, that there are rogue planets out there, like in the trillions, without stars to go around. If you follow what I'm just cruising the galaxy. If it had been one of those, might it have affected us or any of the inner planets?
Have to be super massive.
Yeah.
What would be the odds it could get hooked by the sun and become a 9th planet?
At that
None.
speed, very little.
None.
Yeah. It was moving really, really fast, Ron.
Well, it's a very gloomy thing. These rogue planets, they don't have any light on them. They're just frozen solid, and they're just cruising, and you can't see them.
They're not necessarily frozen solid if they have an active interior.
Oh,
If they still have a molten core.
so they might have life on them somehow that's used to living in the dark on the surface.
Or underground.
Or underground. There you go. God.
Yeah, look at that.
Is that Oumuamua?
Yeah.
Yeah, that looks like the
I think it is.
yeah, you won at the time.
Well, I'm going to give out a prize of 10 extra years on the life of any of you who can spell that damn thing. Is it
It's Hawaiian.
O-U-M-O?
It's down at the bottom of the picture.
There, yeah.
Oh, it is.
Oumua.
Ah, there it is. Okay, now I know.
Spells just like it sounds.
Yeah.
And that means it was found by a Hawaiian astronomer.
Hawaiian telescope.
Telescope.
Yeah.
Amazing.
And, an astronomer that may have been in Hawaii.
So these are common visitors that they've been happening all along. We just didn't know it until recently. We caught up with this.
Quite likely, yeah.
Wow. Amazing stuff.
Space is not that empty.
Well,
So,
we're down to the
if you guys, do you have much more time, Ron?
No, we got about a minute, but go ahead.
Oh, maybe next time. I've just been thinking about an article that came out in Science News that if you guys would like to talk about next week or something. And it's all about the possibility that only planets that have active plate tectonics are capable of producing life. It's really interesting. And the study came out of the Arizona State University.
Oh, there's so many elements in that Drake equation.
Well, if you think of plate tectonics as a carbon recycler, it's a really interesting engine. And I was looking for the article, I couldn't find it before the thing, but anyway, if you guys would like to talk about that sometime, it's really interesting stuff.
Yeah, if you find the article, send it to me and I'll put it and talk.
Okay,
about
sure, Jerry. Science News in January.
All right, we're down to the wire, and good luck to you, and stay safe, and love those wives because they're supporting us. We'll do it again next week for
article.
number 12. All right, everybody. Thank you for watching the SBAU Hour. See ya.
Bye.
Bye.